Okay, so we are on to chapter 3. Now, all of chapter 3 is going to be about linear equations, learning how to find slope, what slope is, practicing more graphing. But today we're going to focus on one thing, and that's to identify linear relationships and proportional relationships. Now, there are some tools that we need to be able to identify either of those. First, I want to talk about what is a linear relationship. This is a relationship, like an equation, where the graph is going to be a straight line, and there's going to be a constant rate of change. Now, what is rate of change? So you will get either a table or a graph, and you will have some value x and some value y. In this case, it's number of songs per minute. And to find the rate of change, we have to compare how our y's change from one answer to another, and the same for x's. So from 0 to 2, that is a change of 2. From 2 to 4, that is also 2. And then 4 to 6 is 2, and 6 to 8 is 2. Okay, now to get from 0 to 1, that's 1. 1 to 2, that's also 1. 2 to 3, that's also 1. And 3 to 4 is also 1. So our rate of change is always 2 on the top and 1 on the bottom. And with 1 on the bottom, that would make it a constant rate of change. Now, constant is another word for same. So for all of these changes from the top and the bottom, it has to say the same rate of change. So because our example up here is constantly 2 over 1, then it is in fact a constant rate of change. We're going to go down to example 1. We have a balance in an account after several transactions as shown. Is the relationship between the balance and number of transactions linear? If so, find the constant rate of change. If not, explain. So our number of transactions is going to be our x values, and our balance is going to be our y values, like the above graph that we talked about. So we're going to go to our x's. We're going to ask, what is the rate of change for each of these? Well, 3 to 6 is 3, 6 to 9 is 3, 9 to 12 is 3. Now let's check our balance. 170 to 140 is minus 30. 140 to 110 is minus 30. And 110 to 80 is minus 30. So if you didn't catch this, 170 minus 30 gives us our next balance of 140. So we're going to take our y and put it over our x. And then we have negative 30 over 3. If you divide this out, you should get negative 10. Now, because it is 3 and negative 30 for each side, this is a constant rate. Now, we are going to practice together. So here we have volunteers and time. Our graph has time. Number of volunteers also, so what we need to do is go to each of these points, and we're gonna write its coordinates. So we have at 8 volunteers, we have 80 minutes. So we're gonna write 8, 80, and write this over here in our table. Now we'll look at 16. We have 16 at 60 minutes. So on our table, we're writing 16 and 60. And then at 24 volunteers, we are at 40 minutes. So we are going to write 24 and 40. Okay, now I'm going to give you guys a moment to find the rate of change so that is telling me from each x to the next, how does it change, and from each y to the next, how does it change? Okay, and then after you find that, I want you to tell me, is it a constant rate? I'm going to give you some time to figure this out. Okay, if you haven't finished, you can pause it, or we can continue and I can show you the rate of change. So from 8 to 16, that's 8. From 16 to 24, that's 8 again. From 80 to 60, that's minus 20. From 60 to 40, that's minus 20 again. So we're going to put our y on top. It's negative 20, and our x on the bottom, that is 8. Now, if you answer that it is a constant rate, that is correct. We have 8's only on the left and negative 20 only on the right. So our constant rate is negative 20 divided by 8, which just simplifies to negative 5 over 2. Okay, if you want to leave it as negative 20 over 8, I am okay with that as well. So we found our rate of change, and is it constant? Absolutely. Okay, for this page, we're going to talk about a proportional linear relationship. Okay, this is slightly different than a normal linear relationship. So if you remember what we just talked about, a linear relationship, we'll say LR has a constant rate of change. This is different from a proportional linear relationship only because of one thing. We still have to have that constant rate of change. Our change in B over change of A, that's what we just practiced. But it has to have a second component. And that is for every B, which we also talked as Y, has to be divided by A or X, and it will all have to be the same number, which sounds confusing, but we're going to look at this example. So we're using this table to determine if there is a proportional relationship, linear relationship, between a temperature in degrees Fahrenheit and a temperature in Celsius. Explain. So let's do the one we know how to do already, and we're going to check that constant rate of change. So the rate of change for each of the degrees in Celsius is 5. Now let's look at our degrees in Fahrenheit. We are going from 32 to 41, so that is a plus 9. 41 to 50 is 9 again, we have 9 again, and then 9 again. So is this a constant rate of change? Well, every time it is 5 over 9. So that is constantly 5 over 9, so it is in fact a linear relationship. Now we have to test if it's proportional. So how we test if it is proportional is by taking our degrees in Celsius and dividing it by that Fahrenheit pair. So let's just take 0 over 32 and 5 over 41. And all we have to do is divide. 0 divided by 32 is 0. And 5 divided by 41 is 0.12. Now, because 0 and 0.12 are different numbers, this is not proportional. Okay? If they were proportional, they would end up being the same fraction or decimal or number. So this is not proportional linear equation. And then we're going to go on to our practice. So what I need you guys to do is to use this table to determine if it is proportional linear relationship between the mass in objects in kilogram and the weight of object in pounds, and explain. So first we're going to find that constant rate of change. So that's, again, going from one box to another and explaining how it changed. So you should have a change of weight on top and a change of mass on the bottom. And if it is constant, then we are halfway there. Your second step should be to test if it is proportionate. Okay? You have to test every weight over mass divided by mass. So that means you're going to take 20 divided by 9 and compare that to 40 divided by 18. And if those are the same, you have to keep going. So if those are the same, we're going to move on and compare 60 over 27. And then 80 over 36. Okay, and I'm going to add my explanation over here in the corner after you guys spend some time practicing. Now, if you are not ready to move on, go ahead and pause the video, and then I'm going to give us a quick explanation. So when we're looking at constant rate of change, we're checking this weight. It's going up by 20 every time. And then our bottom is going up by 9 each time. So because every time is the same, this is a constant rate of change, and I'm just going to leave it as 20 over 9. Now we're checking our proportional relationships. So what you should have done is taken 20 divided by 9, and you get 2.2 repeating. You get 40 divided by 18. And that is also 2.2 repeating. Okay, and we have to keep checking every single option. We got 2.2 repeating again. And 2.2 repeating again. So it is proportional, it is constant, so this is a yes. It is a proportional